Hello, this is part 5, I think now, getting right into the depths of it, of our third person shooter. So last time we developed locking our camera, so it couldn't go too far, too high or anything like that, and what we'd positioned here is really cool and really nice and fun. So now we've got all this sorted. We're now going to start firing from our crosshair in the center of our screen. Obviously, we're going for a kind of Resident Evil-y kind of feel here. So it doesn't matter what kind of the model's doing or any of the animations or anything. The firing is coming straight from the target. So what we need to do is figure out how we're going to do that. How we're going to fire straight through that target using something called Raycasting, which is a part of the physics within Unity. So we'll have a look at the scripting API. We'll have a look at shooting from the center, as well as detecting when we hit a collider, because essentially what a raycast is sending a direct signal straight to an invisible line, straight to another collider. And we want to know what we're hitting. So what we're going to do is also do like a debug.log and put that in there as well. So it will tell us what information we're hitting. So, and at the end of the day, it shows us that our raycast is working. So let's try and get this all done and sorted in this session. Okay, so first thing we're going to do is we're making our game for this is probably going to be for sort of like computer screens and stuff like that, TV screens, etc. So what I'm going to do is change our display from 3 aspect to 16:9, which is a typical kind of television kind of screen. I'm still happy with this. I might move some little bits around, but at the moment with that kind of chopping off of the corners, that's perfectly fine. We're going to do this from the, I'll actually save that, do that from the rest of this video or rest of this game, simply because if I add any more UI elements in, they're not going to get cut off, so I can fit it all into my screen. Okay, so the next thing we need to do, as you can see, we're still on this massively blank canvas here, so what I want to do is be able to create some targets for us. So let's create a cube and see what we can do. Right click, bring the object to cube, bring you up, bring you forward. So you can just have you there, and then we can just duplicate these cubes. There's one there, and there's another one. I'll put it there, so this is a bit of a gap. Cool, so let's rename these target 1, target 2, and you guessed it, target 3. So we're naming these cubes as different names simply because to test that our raycast is working, we're going to shoot a signal, and that signal should bounce back off the collider and tell our debug the name of what target we hit. So if we have target 1, 2, and 3, we know what we've hit specifically with our raycast. Okay. So now we've done that, we are going to look at creating a brand new script for our shooting or our raycasting. So we're going to go create C# script, and I'm going to call this fire. So I've named this like not shooting or gun shooting, or I've named it fire simply because of the input settings that we're going to be mainly using for this. So you may have seen it before when we've created movement using the vertical input settings and the horizontal input settings. So if we go to File, no, Edit, Project Settings, we'll be able to see here where we've used horizontal and vertical before. We have fire 1, fire 2, and fire 3, and we've also, I think we've used jump as well. So if we go and look at, not vertical, look at fire 1, we can see that it's controlled by our left control, or the alternative button is mouse 0, so that's the left click on our mouse. So that's absolutely perfect for what we're going to be doing in our third-person shooter. So we're going to remember to call that up later on within our script. Okay, so we've got our 3 targets, called them, changed our aspect ratio to 16:9. Let us, so what I've done is I've opened up scripting API, and what I'm going to do here is if we type in Raycast, let's see what we find. Okay, so what we're looking for is, there we go, physics.raycast casts a ray from the point of origin in direction of our direction for a length of time from max distance against all colliders in the same scene. It's exactly what we want. We want to be able to shoot everything at the moment. So what we can do is, let's have a look at this. Parameters: origin, direction, max distance. Okay, so we could do either a ball, so if it's true or false. I think we'll probably do an if statement, so if we hit a button, that will happen. And let's have a look what they've got in example. So what's happening in the example? This looks pretty good. Okay, I've got an if for an else, that's quite cool. Raycast hit, named it hit. Physics.raycast. So, parameters. Origin, the starting point of the ray and the world coordinates. Okay, so the way a raycast works is obviously for an order for it to shoot a line of signal to hit a collider or anything within the game scene, it needs to have an origin point. It needs to know where that initial signal is coming from. So this is why we've got origin, and it says the starting point of the ray in the world coordinates. Direction is obviously the direction of what the ray is going in. Like the default direction is just kind of straight ahead of where you are facing. So what we would do is script in our camera. I'm just trying to find an example of where they've scripted in the camera. There isn't one. Oh, actually, no, there's lots more previews here. I can't see anything to do with the camera, so you'll figure that one out. And then after we've got that, max distance, we're not going to do anything for now. We need to do something with hit info. Where's that? There we go, hit info. If true is returned. Hit info will contain more information about where the collider was hit. That's exactly what we want to do, and that's called a raycast hit. Let's actually open that tab and have a look at this one as well. Collider. So the collider that was hit, fantastic. So this raycast hit will definitely probably use as well, and what that will do is tell us what collider we actually hit, or what target in this case we've actually hit. Okay, so the first thing we can do within our script, I haven't actually opened the script, so let's go back to Unity, open our fire script, there we go. Cool, so first thing we're going to do, if we use scripting API as a guide, go back to this tab, void fixed update, if raycast hits, print something. Okay, so what we're going to do first is implement the button that we will press if we want to raycast hit. Okay, so this should be common knowledge to us now. So what that would be is in our update, we're going to say if brackets input dot get button down, and what we're going to do is call up what we saw earlier, what we looked up earlier in the project settings is fire 1, as we know that is the correct project input system we want to use for our third-person shooter. So if we get our button down, we need to say where our initial or where we would like to fire from. So we didn't look at that, did we? Let us have a look at hang on. So if we write Raycast center of screen, that's what happens. Camera dot to screen world point. It could be that. Let's have a look. Screen point. Vector 3, the world space point is created by converting the screen space point at provided distance from the Z point of the camera plane. I don't really want to fight around this. It's not my screen, is it? So what would it be? It'd be my maybe we can just go fire from center of screen Unity. Let's see what happens if you type that in. Shooting to the center of the screen. What are they saying? Hi, the code is used for a laser straight forward. What did they do? Where was that piece of code? Engine.escape. How old is this? 2015. Instantiate. Let's go back. Fire crosshair by directing crosshair in the center of the screen. Oh, let's have a look at that. Where did you put it? Ignore physics, ignore collision. That's not using Raycast though, is it that? Physics dog ignore collision. No, that's not using a Raycast. That's annoying. Oh, come on, there's got to be something. Fire a projectile accurately to the screen across the center of crosshair, aiming at the center of the screen. Make a bullet launch to the center of the screen. Shooting exactly to the center of the screen. Bullet spawner. I think we're getting further away here. Raycast from center of camera Unity. And essentially, okay, let's have a look at this one. So camera.main viewpoint array. So I think this could work. Okay, let's give this a shout. This looks quite good. So what's this? Viewport point array. Okay, let's find this. Viewport to world point. So we looked at some point array. Let's have a look at this. Come on, internet. Okay, so we're going to give this camera.main viewpoint a try. And so it's still, so what I can see here is viewpoint to array, new, oh, here we go, it's loaded. Okay, yeah, so I found my point in the third space. Okay, where's the bit I just saw though? I just saw a bit. Physics.ray, aha. Screen point to ray, maybe. This looks good here on that screen point. On our viewpoint, don't want it to be. Okay, that looks quite good. I'll have to have a look at this in the description API. Okay, so it returns a ray going from a camera through a viewpoint. So we'd have to set that viewpoint. And what they've done here is ray equals camera.viewpoint 0.5, 0.5 to 0. Okay, I'm going to nick this bit, or actually I might nick all of this. This looks quite good. So they've outlined the camera, but we have outlined the camera in a previous script. Let's just make sure that's not locked. It's private, but main. Oh no. If we go camera.main from here, that should be okay because it's just starting from the game. We're not using main._.main. Oh, but we are. Will that work? We'll give that a try. So what we're going to say is we need a vector 3 because we're using the new vector 3. Call this center because that's where I want to shoot from. So that's what they said. Ray. Oh, I don't need that yet. Okay, so what I'm going to say is if we create a vector 3, and which is then equal to a new vector 3, and then we can say, if that's the center of the screen, 0.5f, comma, 0.5f, comma. What did they say? What did it say? 0 for Z. Yeah, that seems logistical. Oh, it's only one bracket. Okay, that works. Then we can say ray equals camera.viewpoint. So I'm going to slightly change that and change that to camera.main. So if we say, we need to say ray, don't we? So we need to say raycast. So we say ray, let's say underscore ray start, because that's our ray origin point. And then that is equal to our camera.main, which would then be dot this viewpoint to ray. That has actually popped up. What have we then got to say? Oh, okay, so it's just the center. So I can then just go brackets. Should be just bracket center. Get rid of that V. Center, close that. Then we can say the information, which is raycast hit. They've called that hit, and so if we say raycast hit is just hit, then we can say if Oh yeah, so if physics dot, oh, it's not there. Hang on, let's go back to our original physics dot. So it should just be physics dot raycast. Why is that not popping up? Pop up, please. Oh, there it is. Physics dot raycast, which will then be our underscore ray start, and then would be oh no, it's going to be out hit. Let's just make sure. What was it? Out. So our raycast. Where's out? Smooth, you need to put out in. Where did I see that? So was it in this one? There it is. Okay, so ray.raycast out hit. Let's just nick it from this. This works. Hit. Then we can say, oh, it's just the debug.log, and then we can say what we've hit, what we've hit, and then we can say it needs to give us the information of our hit info dot the collider, so make sure it hits a collider, and the name of that collider. Oh, it doesn't like that. Okay. Oh, plus name. Why is that name there? Don't know why I did that. Cool. Okay. So, we've stumbled through it, but I think that should give us a raycast. So, we've got the debug.log. So if the debug.log doesn't work and doesn't come up with anything when we shoot our cubes or shoot our targets and doesn't tell us, we know we've obviously gone wrong somewhere. So let's save that. Go back into Unity. Let's make sure on player we have our scripts. Let's add fire. There we go. Fire script is added. Command S very quickly. They're inconsistent lines. Probably stumbled to get that done. Press play. Cool. Let's shoot that target. A hit target 3. A hit target 1 and A hit target 2. Fantastic. So that is working like an absolute dream. So what we're going to do is, if we open this, we can see that we've hit target 3, target 1 and target 2. Absolutely fantastic. The raycasting works. Script and API once again has come through for us. So just as a quick overview, what we have done is we have looked at physics.raycast. We know we need to send a line of signal, but that line of signal needs a starting point, which is our ray start. So physics.raycast, which is underscore ray start. And so that is coming from our main camera and our viewpoint, which has been centered, which is called center, and we named that vector free, so that new transform position, to 0.5f, 0.5f, and nothing on the z. We then said our raycast hit, so this is when our signal has hit a collider. It's going to send back some information. So he said, yep, send back some information, please. So physics.raycast, once we hit the origin and we fire in the direction, the out is going to, with our hit information, is going to send back that information in the form of a debug.log, which send back the information here when we just fired. Okay. Again, we do this to go through the scripting API. We try and use it as much as possible. Okay. It is all very useful. So if you do get stuck or you want to make a more complex physics raycast shooting system or firing system, please use the scripting API as we did here. We stumbled, we fell, but we've brought ourselves back up, and now we're here with a working Raycast system, all thanks to scripting API. Okay, cool. I will see you very soon.